Hello and welcome to another NGen Math 7 video by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 7cc, Lesson 3, the mean as a balancing point. So, we've talked before about statistical questions and certainly you've learned about the mean or the average. Today we're going to be looking at how we can interpret the average in a very particular way. But first, let's do a little bit of review of the mean. All right, so one interpretation of the mean you got in 6th grade math, and let's take a look at it in exercise number 1. 4 friends compare the amount of money they have with them. The amounts were $6, $9, $14, and $19. Find the mean or average amount of money the friends had with them. All right, well, why don't you take a few minutes, all right, using your calculator or doing it by hand, I'm going to do it by hand, and figure out the mean or average amount of money that the friends had with them. All right, well, to find the mean, right, we sum up all of the values and we divide by how many of them are, right? So let's do that. First, let me find the sum, right? The sum is going to be 6 plus 9 plus 14 plus 19. 19 and 14 is going to be 33 plus 9 is 42 plus 6 is 48. So the sum is going to be 48, and that's really $48, right? Right? And then the average, or the mean, is going to be that 48 divided by 4, and that's going to be $12, right? So finding the mean is very, very simple, right? We add all the values together and divide by how many of them are. Now let's take a look at letter B. Why does it make sense to think of the mean as the fair share amount of the data set? Right? So last year you learned that the mean is thought of as the fair share or the equal share amount of the data set. Why does that make sense? Pause the video now and see if you can write something down. It could even be something very specific to this particular problem. All right, well, it's pretty easy, right? If you think about it, if these 4 friends wanted to pool their money and then distribute it amongst everyone, so each person had a fair share, right, they would each get $12. All 4 of them would have $12. So the mean is the fair share amount of the data set because it would be the amount each data point would be equal to if they were all the same, right? And again, that is just literally because of how we calculate the mean, right? How we calculate the mean every time is we take the total of everything, whatever it is. In this case, it was money, but it could be, you know, the total heights of all the plants or the total weights of all the eggs or whatever it is. We sort of throw those into the middle, we add them all up, that's our sum, right? And then we divide by how many data values there are, and that gives us the mean. And that would literally be the process for how we would decide how much each data point would get if the sum was the same, but all of it was distributed evenly or fairly amongst each subject or data point. Okay? In today's lesson, we want to look at a slightly different interpretation. Right? So another way of looking at the mean. Let's take a look at exercise number 2. Consider the 4 numbers or amounts from exercise number 1. Plot the 4 numbers on the number line below and draw a vertical dashed line at the location of the mean. Label the mean. All right, so let's do this together. This isn't that hard, right? I just want to plot those things on the number line, right? I've got big dots. I'm going to put one at 6, one at 9, one at 14, and one at 19. Remember, my mean was 12, so I'm just going to put a little dashed line here right at 12 and write down mean. Okay? Now, let's take a look at exercise number 3. Some of the values in the data set lie below the mean, and some lie above it. State each of their distances above or below the mean in the table below, and we're going to illustrate those distances on the number line. All right, so here we go, right? I'm going to try to kind of keep this all in our view. We got this data value of 6, right, which is sitting down here. And how far is 6 from the mean? Well, remember, the mean is 12, okay? And 12 minus 6 is 6. So this thing is 6 units away from the mean. All right, and it's obviously below the mean, right? Now, we've got that 9, right? And the 9, right, is 3 units away from the mean. Again, we can do that just by subtracting, right? We could do 12 minus 9, which is 3. So that's 3 units from the mean, and that's also below. Okay. Then we've got this value at 14, right? And 14 is above the mean, and it is 2 units above the mean. Again, we can do that by just doing 14 minus 12, or we can just think about it. Above the mean. And then finally, we've got our value way out here at 19, and 19, right, is going to be 7 units above the mean. Right? So this will always be the case, right? Unless you've got a data set where basically everything is the same value, which would be a boring data set. But if you had a data set where you've got all these different values, okay, some are going to be below the mean, some are going to be above the mean. That's just the way it is with a value that's in the center of the data set, okay? And each value is going to be a certain distance either above or below the mean, which you can always find by subtracting, right? So, you could do 12 minus 6 to get 6 units, 12 minus 9 to get 3 units, 14 minus 12 to get 2 units, and 19 minus 12 to get 7 units, right? Now, the question is, what is true about the distances above and below the mean? I'd like you to take a look at this table, take a look at the distances below the mean, take a look at the distances above the mean, and see if you can't make an observation about those. Pause the video now. Well, what I'm hoping that you see is that if I sum the distances below the mean, right? So the distances below the mean, that's going to be equal to my 6 plus 3, that's going to be 9 units. And if I look at my distances above the mean, that's going to be 2 plus 7, that's 9 units. The sum of distances below equals the sum of distances above. Right? It's almost as if coming back, whoops, it's almost as if coming back here, right? It's almost as if the mean is like the fulcrum point on a teeter-totter, right? On a seesaw. And you got all these people that are the same weight. One of them sitting here, one of them sitting here, one of them sitting here, one of them sitting out there. And that mean is the balance point, right? And it balances so that all the distances below the mean are equal to all the distances above the mean. And the wonderful thing about means is that it's always the same. That's always true. The mean is a balancing point. The mean will be located on a number line such that the sum of the distances of the data below it is equal to the sum of the distances of the data above it. In other words, the mean balances the distance above and below it. And that's a very different way of looking at the mean than that equal or fair share value. The equal or fair share value just kind of comes from how we calculate the mean. Oh, we add them all together and divide by how many there are. And there's our mean, right? This is very different. This is like, well, for every 1 unit above the mean in a data set, there must be 1 unit below the mean in a data set in order to have that mean kind of balance everything out. So let's see if we can check that with another data set. Exercise number 4. Given the 5 numbers 2, 3, 7, 13, and 15, do the following. A, find the mean of the 5 numbers. So let's have you do that first just to make sure we're all on the same page. Pause the video now, find the mean of these 5 numbers, and then we'll take a look at letter B. All right, well, whether you use your calculator or do it by hand, let's figure out the mean, right? So the first thing I'm going to do is my sum. Let's see, well, I'll write it out. 2 plus 3 plus 7 plus 13 plus 15. I'm going to go big first. 13 and 15 is 28, plus 7 is 35, plus 3 is 38, plus 2 is 40. So the sum of all my data is 40. And my mean, therefore, is going to be 40 divided by 5, which is equal to 8, right? So my mean is equal to 8. Awesome. Hopefully you got that as well. Now let's take a look at letter B. In letter B, verify that the sum of the distances below the mean is equal to the sum of the distance above the mean. All right, so again, let's think about this. Every one of these data values, right, has a distance away from the mean. Some of them are below the mean, some of them are above the mean. We can always find that distance by subtracting. So for instance, a data value of 2, we can do 8 minus 2, and our distance from the mean is going to be 6 units, and it's obviously below, right? Then we can do our 8 minus 3, and that's going to be 5 units, also below, right? We've got 8 minus 7. That's pretty easy. That's going to be just 1 unit. Notice there are going to be 3 below and 2 above. The number of data points above and below the mean, those don't have to be equal. They do for the median. They don't for the mean. But for the mean, you could have actually all of them below and 1 above. But the distances have to balance. So let's take a look at the 13. Here, 13 minus 8 is 5. So that's going to be 5 units, and now that's above the mean. And then 15 minus 8, that's 7 units above the mean. So now we just want to verify, right? We just want to verify that the sum of the distances below the mean is equal to the sum of the distances above the mean. I think I'll do that right here, right? So below the mean, we would have 6 plus 5 plus 1. 6 plus 5 is 11, plus 1 is 12, right? And above the mean, that's going to be 5 plus 7, and that's also 12. And that is one of the amazing things about the mean. You can always know that however much distance is above the mean is going to be equal to the amount of distance below the mean. And you can use that in a variety of different problems. So let's take a look at a few of them. Exercise number 5. A distribution of 4 data values is shown below. If a 5th value was added such that the mean of the data set was equal to 14, as marked, what is the 5th value? All right, well, see if you can play around a little bit with this problem and see if you can figure out what that 5th and final value would have to be in order for the mean of the 5 values to be equal to 14. Pause the video now and see what you can do. All right, well, again, we know that the distances below the mean must balance or equal to the distances above the mean. Right now, right, what do we have below the mean? At this point below the mean, we only have this one single data point, and it's 4 units. Now above the mean, here we have to be a little bit more cautious. We've got this one, which is 2 units above, and then we've got these 2 at 19. They're 5 units above, but there's 2 of them. We should be careful there, right? Watch out. There's 2 of these that are 5 units above the mean. So in total, we've got 12 units above the mean. So now think about this for a second, right? We've got 12 units above the mean and 4 units below the mean. But if the mean is 14, they have to balance, which means our last data point, right? Our last data point must equal 8 units below the mean. Again, think about why that is, right? We have a total of 12 units above the mean and 4 units below the mean, but these two things have to be equal, right? That last thing, that last one's got to be an 8. Now, I'm not saying that the data value is 8. I'm saying it's got to be 8 units below the mean. So our final data value has to be our mean, which is 14, minus those 8 units. It's got to be 6, right? It's got to be sitting right here. All right? And once you have that, then you've got this point, which is 4 units below the mean. This point, whoops, there it is, which is 8 units below the mean. And those two values, which will give us a total of 12 units below the mean, will balance these 3 data points, which have then distances combined total of 12 units above the mean. Pretty simple. The cool thing is you could now check it. You could actually check to make sure you're right by taking 6 plus 10 plus 16 plus 19 plus 19, dividing by 5, and you would find that the mean was 14. All right, let's take another one like this. Okay, exercise number 6. On Emma's first 4 math quizzes, she earned scores of 79, 76, 87, and 91. Emma would like to score high enough on her 5th quiz to have a quiz average of 85. What would she need to score to have this average? Again, this is a great applied problem, right? This is something you probably have happen to you every once in a while in a math class or other classes, right? You've got certain scores on a quiz, you've got only one test or quiz or whatever left, and you want a particular average on them all, right? What do you need to get that average? Now, there's ways to use algebra to do this, no doubt, but we can use this idea of distances above equaling distances below to get that average of an 85. Pause the video now and see if you can figure out what Emma needs to score on her last quiz to average an 85. All right, well, let's take a look and figure out how many points below that mean we have right now and how many points above that mean. So first, let's go with below. To begin with, right, our 79 is 6 units below, right? Our 76 is 9 units below. And both the 87 and the 91 are above the mean that we're looking for. So we're going to stop right there with 15. Now let's figure out how much we have above that mean. Let me just kind of get rid of these. Now above the mean right now, we've got an 87, that's 2 points above the mean. And we've got the 91, and that's 6 points above the mean. So 8 points above the mean. Now in order to have that mean of an 85 on our final quiz, we must be 8 points above the mean, right? So our final quiz, our final quiz doesn't have to be 8 points above the mean. Our final quiz has to be 7 points above the mean, right? We have to get another 7 here. So it's got to be 85 plus 7, and that's 92, right? And if we get a 92 on that final quiz, then that 92, along with the 87 and the 91, will give us a total of 15 points above our target mean of 85, which will perfectly balance the 15 points below the mean. It's really kind of cool. The mean as a balancing point, right? So you've seen now 2 ways to think about the mean. One way just comes from the way that we calculate the mean, right? The fair share or equal value. Toss all the values in the middle, add them all together, divide by how many there are, fair share value of the mean, right? Or of the data set. On the other hand, right, we have this idea that the mean serves as like a fulcrum or a balancing point. And for every 1 unit that a data point is below the mean, there must be another point that's 1 point higher than the mean or 1 value higher than the mean. Those must balance, right? You can't have 20 units below the mean and only 10 units above the mean. Then that wouldn't be the mean anymore, right? So knowing this idea of the mean as a balancing point is going to be important, not just for you to be able to think about the mean, but also for what we do next. And we'll see that in the next lesson. For now, I just want to thank you for joining me for another NGen Math 7 video by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.